Hey you guys, this is Mr. Sal. This starts a new module 7. We're looking at quadratic equations in this specific one, and we'll be looking at completing the square. So thanks for watching. Don't forget to like, comment, and subscribe. So before we get into completing the square and the polynomial stuff, we just need to understand that if we have a squared equals b, right, and I said, well, solve for a, then you would square root both sides, right? But when this happens, the positive square root of b would give you the correct answer, but also the negative square root of b. Because if we did the negative square root of b, but I squared it, it would be the same thing as just the b, right? Because that's really negative 1 squared times the square root of b squared. I don't know if that helps, but it gets... It gives us our original answer. So if we see squares, we should usually anticipate seeing two answers, okay? All right, find all real solutions of the equation, so we don't have to worry about any of that imaginary garbage. And we got this binomial squared equals some value, so we're going to just square root both sides to get rid of that garbage. But again, when I do that, like we just saw on that last slide, not only do I want w minus 6 to equal the square root of 12, but if I can solve it being w minus 6 equals the negative square root of 12, then I have the correct answers. This should look pretty familiar, right? Kind of like absolute values. Because if you want the absolute value of anything, you just square it and take the square root of it. Okay. So, well, if I were to solve this, for both of these, I would just add 6 to both sides. Now, those aren't like terms because one has a square root and one doesn't. So, in actuality, I have w equals the 6, and that was a positive square root of 12. And then over here, we got w equals, it's the same 6, but it's minus the square root of 12. We just have to be careful because remember the simplification stuff. We do need to be aware of that, especially on the homework, if we wanted full credit. I need to take 12, and I'm going to split it up, the square root of 12, into the square root of 4 times 3. Now, why 4 times 3? Because 4 is a perfect square. So this is really the square root of 4 times the square root of 3, and the square root of 4 is 2. So I have 2 times the square root of 3, and that would be fully simplified. W equals 6, and that was a positive 2 square root of 3. And I can break up this other square root of 12 into 2 square root of 3 as well. So that one gave us W equals 6, but that's minus 2 root 3. And that would be one answer. There's the other one, 2 answers. You won't always be able to square root or simplify that square root, but in this case we were able to, which is kind of nice, just to see that kind of example. Find all real solutions of the equation. Here's what I cannot see on a test, if you want full credit, or any credit for that matter, is to square root this and to square root that. Okay, just like, I mean, you know, just like we saw with the absolute values, we don't want that garbage. Like if that was an absolute value right there, you'd have to add 18 to both sides before you were solving it, right? So don't do that, please, so that you can get full credit. Add 18 to both sides, right? Because we are manipulating or solving these equations for the actual squared expression. Well, we've done just that with the manipulation stuff. So I'm going to square root both sides of this. And we can look at 18 just to see if it splits up well, and it does with 9 and 2, right? Square root of 9 times 2, which is 3 times the square root of 2, because 9 is a perfect square, right? So this equals now 3j plus 4, but that's only one of the expressions. I should have written that closer. So there's our two expressions, right? It split up, again, just like it did, or it would with absolute value. And we're going to solve this just as usual. I'm going to have to subtract 4 from both sides of both equations. Let's subtract. So what does this give us? I got that 3j left over. And this equals negative 4. I can't combine those two because they're not like terms. Minus 3 root 2. Oh, by the way, if for some reason you did combine them, I mean, I could probably get you a couple points for the, simplification and stuff, but not very many. I need to see on the test that you guys know not to combine unlike terms. All right, we got 3j equals, now it's, well, we still got negative 4. But now this is a positive 3 root 2. From here, we're just going to divide all the terms by 3 so that we can just get j for both equations. And now we'll simplify this. I got j equals negative 4/3. Minus 3 divided by 3 is 1, so that's really just 1 root 2. And then over here I've got j also equals negative 4/3. Plus, again, that becomes a 1. 3 divided by 3 is 1 times the square root of 2. And we got our two answers down here. Put a comma between them if you want. Solve by using the square root method. If they're telling you to use a specific method, that means there is another method. And there is another method. We just don't know what it is yet. But we will find out in the next section. Some of you guys already know what it is, and that's okay too. All right, we need to manipulate this equation so that we just have the a's on one side and the numbers on the other. All right, some of you guys are, again, tempted to just square root both sides and feel good about that, but don't. You don't want to do that. I'm going to subtract 180 from both sides, right, manipulating the equation. Well, this is looking pretty good, but if I can just solve for the a squared, then we'll be in even better shape. So I'm going to divide both sides by negative 20. Now that I got a squared is 9, I can just square root both sides. But again, this is going to produce two different results for us. A is the square root of 9, which is a perfect square. A is 3, but a could also be negative 3. You could try that, right? If you did negative 3 squared, it would still give you a positive 9. So there's our two answers. Find all solutions, real or non-real, of the equation. And usually if they ask for both types, there usually is both types. But we can't really expect that all the time. And here's why. So just solving this, right, we'd add 15 to both sides first so that we have isolated the expression that's squared. Okay, well, just taking the square root of both of these gives me 5s minus 8 equals positive 20, and that would be my first branch, but I got a second one as well, right? 5s minus 8 also, that's a square root of 20, sorry, is the negative square root of 20. Now 20 could be simplified, right? 20 is the same as 4 times 5, and 4 is a perfect square. So it's really 2 times the square root of 5 for both. Well, just solving regular equations now. We're going to add 8 to both sides of both equations. Well, all we need to do now is divide all the terms by 5 so that we have just the s on that. And we've got to be careful also. I can't take the square root of 5 and divide it by 5 to be 1, right? Because they're not really like terms. So what do I got? I got s is 8/5 plus 2 root 5/5. There's both our answers. One answer, two answers. Yeah, so again, it did ask for non-real solutions, but all of them are real. Those are real. Solving a quadratic equation in x by completing the square. So we got to make sure, first of all, that the coefficient of x squared is 1. So we would divide all the terms in the entire equation by whatever the coefficient of x squared is. All right. I mean, this is if assuming there's no simplification needed, meaning combining like terms. After we do that, then we put all the variable terms on one side, right? So if we were to look at a quadratic is just a polynomial with a degree of 2, by the way. If I were to look at something like x squared plus x minus 5 equals 0, I mean, that's pretty nice, but I need all the x's on one side, no numbers. So I would want to change that. Instead of minus 5, it would equal positive 5 now, right? Adding 5 to both sides. That's pretty crucial when we complete the square. So keep that in mind. But once we do that, then we will complete the square for the resulting binomial by adding the square of half the coefficient of the degree 1 term. So we're just looking at the coefficient of x, dividing it by 2, and adding it to both sides. So let's change that coefficient of x to, we'll make it even 4, okay? Now, I forgot, at the last part of that, it should have mentioned squaring it. So I got to take 4, which is the coefficient of x in purple there. I would divide it by 2, which is 2, square it, which is 4, right? And then I add it to both sides, right? Because that plus 4 came out of nowhere, so if I do it to one side, I got to do it to the other side. The nifty thing about this is if I use, well, this gives us what is a perfect square trinomial, right? A squared plus 2ab plus b squared stuff. I mean, you can use the minus stuff as well. And then I would be able to just change that into x, right? That's going to be squared. And then this would be plus 2 squared. But it would equal 9 now in this example that I got. Again, I'm using the rule on that. And then using the square root property, I would square root both sides. And that square root of 9 is going to split up into two values, 3 and negative 3. Which would then allow me to solve for x both times. Now we've got to keep in mind, since these are quadratics, or polynomials with a degree of 2, we should expect two answers, whether they're imaginary or real. Solved by completing the square? Okay. So we look at this one. We start with seeing that the coefficient of x squared is 1, which is good. We do want that 1 to be there. But what I don't want now for step 2 is to see that plus 33, because I just want the variables on one side of that equal sign. So I'm going to subtract 33 from both sides of the equal sign. So now I got x squared plus 14x equals negative 33. Well, what I got to do now is look at my coefficient of x, which is positive 14. So to complete the square, I'm going to take that 14, and I'm going to divide it by 2, and I'm going to square whatever that result is. So 14 divided by 2 is 7, and if I square that, 7 squared is 49. That's positive 49, so I'm going to add 49, not only to one side, but to the other side as well, just to keep it balanced. So this is my new expression. And again, that plus 49 gives me a perfect square trinomial, all right, which allows me to break that up into one binomial that's squared. And, I mean, you could take the 49 and square root it, right, which is positive 7. And this equals now negative 33 plus 49, which is 16. And that's extremely generous and kind of them, because that is a perfect square. Well, from here, I've got a square that's equal to something, so I'm just going to square root both sides, which is going to give me two different expressions. X plus 7, which we've already square rooted, it's squared, so it's just x plus 7. The square root of 16 is 4, but it would give me a second expression, x plus 7 equals negative 4 as well. And to solve both of these, not too bad, right? Just subtract 7 from both sides. And now I've got x is negative 3, but also x is negative 11. I don't know. We did talk about this before, right? With the square rooting stuff. You should check this just to make sure, because if we remember right, when we square root both sides like this, it just means the answers that we get are among the solutions, which means they may not always be part of the solutions. Okay. But this is good. These work.
When you do that, would you go back to the original?
By completing the square, we'll solve this for x. Now again, we got a coefficient of x squared, which is 1, which is what we want. But I don't want that minus 8 because it doesn't have an x. So I'm going to add 8 to both sides of this equation. Now again, I need to look at the coefficient of just x, which is 2. I'm going to take 2. I'm going to cut it in half, but I'm going to square whatever that is. So that's really 1 squared, which is 1. So I'm going to add that to both sides of the equation. If I do it to one side, got to do it to the other side. Well, that changes, right? Because now, again, I got a perfect square trinomial. And this now is going to become x plus that 1 squared. And this equals 8 plus 1, which is 9. Again, a perfect square. That is not coincidental. And we'll square root both sides, giving us two different expressions. X plus 1 equals 3, but also x plus 1 could equal negative 3. Well, I mean, if we had started with a problem like this, I mean, maybe the next time we see something like that on the final, right, we would have loved it, because we just subtract 1 from both sides, and then we're done, right? So x is negative 4, but also x is 2. Well, you know, we should check that, but I did already. We're good. Once again, completing the square. They didn't give us a coefficient of x squared other than 1, and that's nice. And, well, we don't want that minus 19 there, so we're going to add it to both sides. This one may, I don't know, it may come out a little freaky because 5 is not even, right? So I look at my coefficient of x, which is 5. I'm going to cut it in half, but I'm going to square that action, which would mean I'm going to square both of those, right? Giving me 25/4, which I'm going to add then to both sides of the equation to keep it balanced. Now that's all fine and dandy, right? I mean, I could take this and say, well, I got x plus 5 halves squared, so that's my perfect square trinomial, which is what completing the square always does for us. But that 19 plus 25/4 is not as convenient, all right? So I'm going to have to multiply the numerator and denominator by 4, which changes that to, and then I'm going to combine those fourths into 101/4. All right, let's go ahead and square root both sides of this. The nice thing about what we're seeing on that right side of that equal sign is the denominator is 4, which means that's going to be the square root of 101 halves. I shouldn't have put that there. All right, well, let's subtract 5 halves from both sides. I should use a different color. And just for formality's sake, I mean, not that I would care if you guys wrote it like that, but it appears that they wanted on the homework to be negative 5 halves. And that would be plus square root of 101 halves. And then this other one, negative 5 halves still, but minus square root of 101 over 2. Now, could you combine this into one term? It looks like on the homework that they did. But for me, I'm okay just leaving them like this. So that's where I'm going to stop. Solve this by completing the square. All right. Well, we don't want that plus 6 there. And we do have a coefficient of x squared, and that's 1. That's good. So I'll subtract 6 from both sides. So what are we going to do? We're going to take the coefficient of x, 2. We're going to divide it by 2 and then square it. So that's 1 squared, which is 1, positive 1. And I'll add it to both sides. Now I've got that perfect square trinomial, which gives me x plus 1 squared, equals negative 6 plus 1, which is now negative 5. And some of you know what will happen now that we get to this point. Square rooting both sides gives us the square root of a negative, which is what we don't want for the most part. But because of 6.9, we know that it's going to be I square root of 5. So I got x plus 1 equals I square root of 5, but also x plus 1 could equal the negative I square root of 5. Well, this one, again, still not too bad. We'll just subtract 1 from both sides of both equations. And I got x equals negative 1 plus I root 5. But x also equals negative 1 minus I root 5, just the conjugates, right? And that's our answers. All right, here's another one that just gave us one of the values on the right side. But that's where we wanted it anyways, that positive 21. So I'm going to have to subtract 41 from both sides, though. And then we'll complete the square. Right? Now the coefficient of r in this case, just not x, it's actually negative 4. And we're going to divide that by 2 and square it. So that is going to be, well, it'd be negative 2 squared, which is 4. So I'm going to add 4 to both sides. Which is nice because on the right side, it's still, I mean, it's negative, but it's a perfect square, 16. And we can take that perfect square trinomial. This one is minus, and we remember inside the parentheses, it's simplified into a negative 2, right? So it really ends up being r minus 2 squared. Well, this will split up in two separate equations, r minus 2, right, because we're going to square root both sides. R minus 2 equals 4i, but r minus 2 equals negative 4i. And I got that, the 4 i's from the negative square root of 16, which would be I, and then the square root of 16 is 4. We just make it 4i though. Now to solve, we'll just add 2 to both sides of both equations. And we can't combine those because they're not like terms. So I really have 2 with a positive 4i. And then on this other one, r equals still positive 2, but now it's a negative 4i. And that's my two answers. We're just filling in the blanks for A and B on this. But we'll do it by completing the square, right? So I'm going to kind of ignore that, what the question is right here. Okay. So, I mean, if I were to look at this completing the square, I would make this x squared plus 2x. And I'm going to separate the 39. Now, since this is not really an equation anymore, because we don't know what it equals, and we don't really care, I can complete the square for that x squared plus 2x, right? I got 2, but I'm going to divide it by 2 and square that. Square that. That should be, there we go. Which is 1 squared, which is 1. So I'm going to add 1 right there. But since we're on the same side of an equal sign, I got to be able to cancel out that plus 1 stuff by subtracting 1 also. Right there. What that does is it gives us this perfect square trinomial right there, which is x plus 1 squared. But then I need to combine that 39 with the negative 1, which is positive 38. So if we look now back at the original question, because we want to find A and B, right? Well, we can see then that A is 1 and B is 38. A is 1, B is 38.